Hello everyone, welcome. This is your elective subject, hardware and PC maintenance. So now let us see the microprocessor. The central processing unit CPU does most of the calculations that make your computer a computer. The CPU, also known as microprocessor, so it hides on the motherboard below a large heatsink and often a fan assembly as well. So CPU makers name their microprocessor in a fashion similar to the automobile industry. CPUs get a make and a model such as Intel Core i7 or AMD FX 8350 Black Edition. So here the CPU core components. A CPU functions more like a very powerful calculator than like a brain. Okay. So today's CPUs add, subtract, multiply, divide and move billions of numbers per second. So processing that much information so quickly makes CPU it look intelligent. So the quickly processing of information makes the CPU intelligent. So it's simply the speed of the CPU rather than actual intelligence that enables computers to perform facts such as accessing the internet, playing games or editing photos. Okay. So here the concept of a man in the box. So here just visualizing the CPU as a man in a box. This is one clever guy. So he can perform virtually any mathematical function, manipulate data and give answers very quickly. So here before he can work with us, we must come up with a way to exchange information with him. That just imagine we have installed the set of 16 light bulbs, 8 inside his box and 8 outside the box. Each of 8 light bulbs inside the box connects to one of the 8 bulbs outside the box to form a pair. So each pair of light bulbs is always either on or off. You can control the 8 pairs of bulbs by using a set of 8 switches outside the box, and the man in the box can also control them by using an identical set of 8 switches inside the box. So this light bulb communication device is called external data bus, EDB. So here these 8 switches from inside and 8 bulbs from outside. So both the user and the man inside the box can control these switches. Okay. In computers, wires repeatedly turn on and off. As a result, we can use this 1 and 0 or binary. So binary is called always 1 and 0, and on and off, 1 for on and 0 for off. So this binary system describes the state of these wires at any given moment. So now the registers. The man in the box provides good insight into the workspace inside a CPU. The EDB gives you a way to communicate with the man in the box. So you can give him the instructions, that means the work to do. But to do this work, he needs a work table. In fact, he needs at least 4 work tables. Each of these work tables has 16 light bulbs. These light bulbs are not in pairs. They are just 16 light bulbs lined up straight across the table. So each light bulb is controlled by a single switch operated only by the man inside the box. Okay. So by creating on or off patterns like the ones on the EDB, the man in the box can use these 4 sets of light bulbs to work math problems. So in a real computer, these work tables are called registers and store internal commands and data. So these registers are controlled only by the CPU, okay, not by the user. So this is typical registers. All CPUs contain a large number of registers, but for the moment we just concentrate on the general purpose registers. There are 4 general purpose registers. Intel named them AX, BX, CX and DX. So for example, 1 0 0 00111 means move the number 7 into the AX register. So these commands are called microprocessors. Machine language. So microprocessor uses machine language. So this is the 10000111. It means move the number 7 to AX register. Okay. So it uses a byte. The AX register is of 16-bit. So by placing machine language commands called lines of code onto EDB one at a time, you can instruct the man in the box to do specific task. All of the machine language commands that CPU understands make up the CPU's instruction set. Okay. So here using EDB, the user can give the instructions to the CPU. So here there is one more concept, the clock. To add two numbers, you pressed a number key, plus key, and another number key to add two numbers. But then to make a calculator to do the calculation and give you the answer, you had to pull down the crank. Okay, that was the signal that you had finished entering data and instructions and were ready for the calculator to give you an answer. Like we enter the enter key. Okay. CPU also has a type of crank to return to the man in the box. Imagine there is a bell inside the box activated by a button on the outside of the box. Each time you press the button to sound the bell, the man in the box reads the next set of lights on the EDB. Of course, a real computer doesn't use a bell. Okay, the bell on a real CPU is a special wire called a clock wire. So here bell is a clock wire, but there is no bell, but the bell concept is given for the clock wire. So a charge on the clock wire tells the CPU that another piece of information is waiting to be processed. A charge on the clock. Okay. The maximum number of clock cycles that a CPU can handle in a given period of time is referred to as its clock speed. So the clock speed is the fastest speed at which a CPU can operate, determined by the CPU manufacturer. So the Intel 8088 processor had a clock speed of 4.77 MHz, 4.77 million cycles per second. Extremely slow by modern standards, but still a pretty big number compared to using a pencil and paper. Okay, CPUs today run at speeds in 3 gigahertz, that is 3 billion cycles per second. 1 hertz means 1 cycle per second. 1 megahertz means 1 million cycles per second. 1 gigahertz means 1 billion cycles per second. Okay, 1 billion instructions per second. 1 gigahertz means it is the speed of the processor is it can process 1 billion instructions per second. So now the memory. Computers need some other device that takes copies of programs from the hard drive and then sends them one line at a time to the CPU quickly enough to keep up with its demands. So because each line of code is nothing more than a pattern of 8 ones and zeros. Okay, any device that can store ones and zeros 8 across will do. Devices that in any way hold ones and zeros that CPU accesses are known generically memory. So because the computer can understand only zeros and ones, so there are 8 ones or 8 zeros, and there will be the patterns of ones and zeros. So memory can access only these ones and zeros, and these 8 ones or 8 zeros or the any patterned zeros and ones. And memory and RAM. Memory must store not only programs but also data. The CPU needs to be able to read and write to this storage medium. So additionally, this system must enable the CPU to jump to any line of stored code as easily as to any other line of code. So all of this must be done at or at least near the clock speed of the CPU. So the magical device has existed for many years, that is called random access memory or RAM. So computers use dynamic RAM for the main system memory. Dynamic RAM needs both a constant electrical charge and a periodic refresh of circuits, otherwise it loses data. Okay, and RAM, so that's why it is called dynamic rather than static in content. So dynamic means if the power goes off, the content will be lost. Okay.